My name is Kindson, and this will be part 9 of our PyTorch tutorial for absolute beginners. And in this part, we are going to train our model. We are going to spend some time here. So let's see. So we are going to train this model. If you are joining me for the first time, please remember to subscribe to my channel so that you don't miss any updates. So first, let's examine the size of our training data set. So I'm going to say size. Actually, we're also going to use this size. We want to print out the metrics for the training, or the training metrics. So train data loader dot datasets, okay, and we are going to call model dot train. So the question now is, how do we train this data, right? So we call model dot train, that's fine, but we want to train this in batches. So we are passing the data through this network. We are performing some calculation. The calculation we are going to be performing is the loss. We are going to calculate the loss, making a prediction, calculating the loss, and then we are feeding back or back propagating the loss back into the network to adjust the weights, and we repeat this process many times until the results are accurate. Okay, so I'm going to write a loop for performing the training in batches. So it's going to be for batch xy in our training data loader, train data loader. Okay, so we have batch xy in enumerate train data loader, and we are going to move to the CPU x.2 device is CPU. We also move the labels to device as well, y.2. Okay, so now we have to do a forward pass. In the forward pass, we make predictions and calculate the prediction loss. Forward pass, because the loss is what you are going to use to feedback, back propagate the loss and use it to adjust your weight. So let's call this y predicted. And we are going to use the model to make this prediction. So initially, for sure, this prediction was going to be very wrong, or maybe not accurate. So we are going to calculate the loss. We are going to actually need a loss function. So I forgot to mention this. Okay, to calculate the loss, we need a loss function and also an optimizer. So to be able to make a forward pass, we need to calculate, or we need to make prediction, right? And we also need to calculate the loss. To calculate the loss, we need a loss function. And the loss function we are going to use is available. So the loss function I'm going to use is cross entropy loss. So I'm going to create this loss function. It's going to be nn.cross entropy loss. We also need an optimizer. I'm going to create an optimizer. So an optimizer performs optimization using the model parameters and a learning rate. So I'm going to create an optimizer, I'm going to be using stochastic gradient descent optimizer, and I'm going to give it the model parameters. And we also need to provide a learning rate. So let's give it a learning rate of 0.001. So LR is equal to, let me define the learning rate separately. So I'm going to say learning rate is equal to 0.01. So you may be asking, what is the learning rate? Learning rate is used to set how the weight of the network changes. So how frequently do you want to adjust the weight of the networks based on the loss computed? So the LR is learning rate. So I'm going to give it a learning rate of 0.01. So it's going to be learning rate of 0.01. And at this point, we'll continue to go on to calculate the loss. So we are going to calculate the loss using the loss function, and we are going to give it the predicted value, y predicted, and we are giving it the actual value. So we have the actual value and the predicted value, and the loss will be computed. So this is a forward pass, right? So we are at this point now, it's made some computation here which is not accurate. We want to feedback or back propagate into the network so that the weights will be adjusted. So I'm going to make a comment here. So I'm going to do a backward pass. So what happens in the backward pass? Give me a second. We are going to compute the gradients and we are going to back propagate the loss to adjust the weights, and then we are going to empty our gradients. So the first thing we are going to do is to compute the gradient. So given the loss function and given the actual value, we compute the gradients. So I'm going to say loss dot backwards. So this computes the gradient, this line, and the second line we are going to then optimize by backpropagating the loss and adjusting the weight, and that is done in the optimize step, optimizer.step. So take note of what is happening. Here we compute the gradients, and here we adjust the weight at this point. Now, before we move on to the next iteration, we want to also empty the gradients. We want to empty the gradients so that we prevent accumulating gradients from previous iterations. So we are going to reset the gradients more or less. So I'm going to say optimizer dot zero underscore grad. All right, so this is what we have at this point for our model training. So once you run this, the model gets trained. Hopefully I didn't make any mistakes. So the question now is, how do we actually see that the model is being trained? So this we are going to do in the next tutorial. We are going to actually run the training and see the loss, and actually see how the loss is actually reducing as the model gets trained with each iteration. I'd like to stop here. I would like to thank you for viewing. Also remember to subscribe to my channel and leave me a comment if this has been informative for you.